Hi, I'm Patrick Reagan. This video, TCP/IP Part 11, IP version 6 and IP version 6 addresses, starts the discussion on IP version 6, which is the most recent version of the Internet Protocol. It starts discussing what is IP version 6 and its characteristics, its benefits, IP version 6 addresses, and the types of IP version 6 addresses. If you like my video, don't forget to click the like button. If you have not already, subscribe to the Pat Has Your Back channel. As with most of my videos, there are practice questions at the end of the video. You might have heard that available public IP addresses are running low, which only has around 4.294 billion public or global unicast IP addresses available. To overcome this problem as well as a few others, IP version 6 was developed as the next generation Internet Protocol version. IP version 4 is now part of all major operating systems and is the backbone of the Internet infrastructure. Internet Protocol version 6, or IP version 6, is the most recent version of the Internet Protocol, which is the core set of rules that governs how data is addressed, routed, and delivered across networks. The version number for IP version 4 and IP version 6 is found in the first 4 bits of the IP packet header. IP version 4 packets start with 0100, which is binary for 4, while IP version 6 packets start with 0110, which is binary for 6. IP version 6 provides a number of benefits for TCP/IP-based networking connectivity, including 128-bit address space to provide addressing for every device on the Internet with a globally unique address. There are approximately 3.4 times 10 to the 38th power, or 340 unit decilons, IP version 6 global unicast public addresses available. It has more efficient routing than IP version 4 and support for automatic configuration. It has enhanced security to protect against address and port scanning attacks, utilization of IPsec to protect or encrypt IP version 6 traffic, data origin authentication to verify the identity of the sender, which should help with prevent IP address spoofing, and integrity checking to ensure data was not altered in transit. Disadvantages of IP version 6 include transition period. Due to the widespread use of IP version 4, shifting completely to IP version 6 will take a long time. Communication barrier. IP version 4 and IP version 6 machines cannot communicate directly with each other. No backward compatibility. IP version 6 cannot run on IP version 4 capable computers because it's not supported by IP version 4 systems. Conversion challenges. IP version 6's inability to uniquely identify each device on the network makes the transition from IP version 4 time-consuming. Because IP version 6 uses 128 bits, the addresses are usually divided into groups of 16 bits, written as 4 hex digits, which each hexadecimal number represents a nibble of data. Hex digits include 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, and F. The groups are separated by colons. An example is shown on the screen. Similar to the IP version 4 addresses, IP version 6 is divided into network bits and host bits. The first 64 bits define the network address, and the second 64 bits define the host address. For our example, the first 16 hexadecimal digits define the network bits, and the last 16 hexadecimal digits define the host bits. Initially, the network bits are further divided where a block of 48 bits is used as the network prefix, and the next 16 bits are used for subnetting, which allows up to 65,536 subnets. Now, the recommended IP version 6 address division is IPS prefix is 32 bits, which is assigned by the upstream provider. Customer site prefix of 16 bits defines the customer site or organization under the ISP, and the subnet ID is 16 bits used by the organization to divide their site into multiple subnets. The interface ID is 64 bits, which identifies the specific host or interface on the subnet, which is required to be 64 bits for SLAAC. For an IPv6 address, 0000 can be written as just 0. The block is set to 0 and is followed by another block set to 0. It can be written as : as shown on the screen. With IPv6, unicast address can be divided into global unicast addresses, which are public addresses that are globally routable and reachable on the IPv6 portion of the internet. It begins with 2000:/3, which starts with the binary value of 001, through E000:/3, which starts with the binary value of 111. Unique local addresses, or ULA, is meant for private addresses with the addition of being unique so the joining two subnets does not cause address collisions. They start with FC00::7. Each ULA prefix is unique with the global IPv6 address space, ensuring no conflicts when different sites or organizations. These addresses are not routable on the global internet, but are routable internally. They're designed for private networks, enabling communications within a site or between a limited number of sites without requiring internet connectivity. Linked local addresses are private non-routable addresses confined to a single subnet. They start with FE80::10. They're used for communications between devices on the same physical or logical link, like a local area network or VLAN. They're used by hosts when communicate with neighboring hosts on the same link, including Neighbor Discovery Protocol, or NDP, and automatic address configuration. They can also be used to create temporary networks for conferences or meetings, or to set up a permanent small LAN. Devices automatically assign themselves linked local addresses through a process called linked local address auto-configuration, also known as auto-IP or stateless address auto-configuration. Since many interfaces may use the same linked local address range, the operating system must know which interface to use. At the end of the linked local address, you will find the zone index or interface identifier, which tells the operating system which network interface the address is associated with. For example, Windows has a % followed by a number, which is the zone index, and Linux has a % followed by the interface identifier. Without this index, the OS or device wouldn't know which interface linked local address you're referring to. In Windows, to see which number goes with which interface, use the command shown on the screen, and to show the Linux interface, execute the command shown on the screen. If you see a preferred at the end of the IPv6 address, the address is fully usable for sending and receiving traffic, which can be used for initiating outbound communications. If you see a valid at the end of the address, it's still usable for receiving traffic, but it should not be used as the source address anymore. If marked deprecated, it is still technically valid or receivable, but it should no longer be used as the source for outgoing connections. This is governed by the preferred lifetime and valid lifetime in IPv6 address configuration, typically provided by router advertisements during SLAAC, DHCP version 6, and manual configuration. The IPv6 loopback address is : 1. Embedded IPv4 addresses in IPv6 work through a process where a standard IPv4 address is incorporated into the lower 32 bits of an IPv6 address, or transition and interoperability between the two protocols. This allows IPv6 capable devices to communicate with IPv4 only networks, or devices that can use IPv4 mapped IPv6 addresses. These addresses are written with 96 bits of zeros, followed by 16 ones, such as 0:0:0:0:0:0, :FF, :A.B.C.D, whereas ABCD represents the standard IP version 4 address. An example is shown on the screen. It is common in dual stack systems where an application handles both IP version 6 and IP version 4. Multicast addresses identify a group of interfaces typically across different devices. Packets sent to a multicast address are delivered to all interfaces identified by that address. Types of multicast addresses include well-known multicast addresses, which are reserved addresses for predefined groups, such as all nodes on a link. Some of the more common ones are shown on the screen. The solicited-node multicast addresses are used for neighbor discovery. Here we have a breakdown of the various types of IP version 6 addresses. The unicast address include global unicast, link local, loopback, and unique local addresses. Global unicast addresses are globally recognized and unique, while unique local addresses are only within the organization. While both are routable, only global unicast address is routable over the internet. Unique local is for internal use only, while link local address is for link local scopes. For a host to communicate on a network, typically needs an IP address, which is a unique logical address assigned to the host, subnet prefix length, which specifies which bits of the IP address is network bits and which bits are host bits, and a default gateway, which is the IP address of the nearest router, which allows communications with other network. It will typically also need DNS server, which is the IP address of a DNS server, which will provide name resolution to IP address. When manually configuring IP version 6 in the Windows TCP IP version 6 settings, you configure a unicast address, either global unicast or ULA, depending on whether the address is meant for internet routable or internal private use. Here, we're showing running the ipconfig/all command, showing your IP version 4 and IP version 6 addressing. Question: how many bits is an IP version 6 address? Answer: 128 bits. Question: what type of address is shown on the screen? Answer: IP version 6 address, specifically a global unicast address. Question: what type of IP version 6 address is a public address that is routable and reachable on the internet? Answer: global unicast address. Question: what is the successor to IP version 4? Answer: IP version 6. Question: you have the following IP version 6 address shown on the screen. Which of the following is the proper shortened version? Answer: D. For more information, refer to these sites. In summary, IPv6 provides a number of benefits for TCP/IP-based network connectivity, including 128-bit address space to provide addressing for every device on the internet with a globally unique address. Because IPv6 uses 128 bits, the address is usually divided into groups of 16 bits written as 4 hex digits. A global unicast address is a public address that is globally routable and reachable on the IPv6 portion of the internet. The IPv6 loopback address is : 1. For a host to communicate on the network, it typically needs an IP address, which is a unique logical address assigned to the host, prefix length, which specifies which bits of the IP address is network bits and which bits are host bits, and a default gateway, which is the IP address of the nearest router, which allows communications with other networks. The DNS server is the IP address of the DNS server, which will provide name resolution to IP address. Thank you for watching this video. The next video will be TCP/IP Part 12, more on IPv6. If you like this video, be sure to click the like button. And if you have not already, subscribe to the Pat Has Your Back channel. Thank you.